All right, guys. Last time we looked at parallelograms. And if you can see here, there's 6 different ways for us to know whether the quadrilateral, the four-sided shape that we're looking at, there's 6 ways to know whether that quadrilateral is a bit more advanced and possibly is a parallelogram. So 6 ways to know whether you're looking at a parallelogram. Now, one thing I want you to look at is this quadrilateral family tree. This can be found on my Schoology course, but be very careful here, all right? It even says right here, these are characteristics, not conditions. So there's a bunch of conditions that you get if you have a parallelogram. The opposite sides are parallel, the opposite sides are congruent. These are often a lot like the conditions, but some are just a tad bit different. So this document is important to know all of the goodies that you get along with these shapes. The conditions are a bit more interesting and specific, so you're certainly going to want to get these written down as well. So when we're talking about today, we're going to progress past parallelograms to what we call special parallelograms. So if you're looking at this family tree, all right, the grandfather is called quadrilateral. As long as we have 4 sides, we're talking about all of these shapes here, all right? We progressed on to a parallelogram. Now, one of the things that a phrase I want you to kind of get used to, all right, is if we were in class, I would be writing this on the board. I would say, hey, let's make sure and walk the path, which just means, because we're going to start looking at special parallelograms. If we have a parallelogram, it's possible for a parallelogram to be more special if it happens to be. So there's 2 kinds of what we call special parallelograms, all right? The rectangle, which is a parallelogram that is equiangular. Once all the angles are the same, then that parallelogram becomes a bit more special. We give it a more special name called a rectangle. If that parallelogram happens to be equilateral, we have what's called a rhombus. And we're going to go over the conditions in a second here. And if you have a parallelogram is not only equiangular, but also equilateral, that's when the only time you can come all the way down here and get to a square, but you can't skip any steps. You have to know you have a parallelogram first before considering whether you might also have a rectangle or a rhombus, which is a more specialized version of a parallelogram. Okay, so let's look at these conditions. All right, so there are 6 different ways to know whether we're looking at a parallelogram. If you know you have one of these 6 conditions, now we can progress further. All right, for a rectangle, there's 2 ways to know whether you have a rectangle. One, if the diagonals, right? We already know if we have a parallelogram, we already know that the diagonals cut each other in half. But if the diagonals actually end up being congruent, all right, and what that would look like on a diagram is instead of knowing that they just cut each other in half, then all 4 of these pieces would have to be the same. Okay. Now, here's where it's a big deal to consider the difference between a characteristic of a rectangle and the conditions, because a rectangle, you probably all know there are 4 right angles, but the question is, how many of those angles do we need to know are right angles before they're all going to be right angles? And actually, we only need to know that there is 1 right angle. But again, this only works if we already know that we have a parallelogram. All right, we got to have a parallelogram before we can progress further. All right, so again, as long as I knew that one of these angles was a right angle, because if I know I have a parallelogram, then I know if this is 90 degrees, the one across from it's also 90 degrees. If I have a parallelogram, I know that the consecutive angles are supplementary. So if this is 90, that'll be 90, and the other consecutive angle will be 90. So we really only need to know that one of the angles is 90 degrees, and then I know they all will be 90 degrees. These are the two ways to know whether we can progress from a parallelogram and go further and say our shape's more specific. It's more than a parallelogram, it's a rectangle, okay? And there's three ways to know whether you have a rhombus, okay? So let's cover those. The first one, if we know that the diagonals are perpendicular. That perpendicular word shows up all the time in mathematics. Let's try and remember what that means. If our diagonals are perpendicular, that means we have, hold on, that means we have 90 degrees here. In the middle, all right? It's a very special occurrence with rhombi or rhombuses, all right? Also, and this is a little bit more tricky, if we have one pair of congruent consecutive sides, one pair of congruent consecutive sides. So what that means, if I knew that this side and this side, because remember consecutive means next to, okay? Because remember, if we have a parallelogram, we already know the opposite sides are congruent. If I know two of the sides that are next to each other are congruent, then they will all be congruent. And try and remember that's what we're talking about with a rhombus, all right? And the last condition, if one diagonal bisects both angles. So I've drawn one diagonal here. If we know that that one diagonal has cut this angle in half, and done the same up here, then that parallelogram will be more than a parallelogram, and it'll actually be a rhombus. And again, remember, if you have one of these two scenarios and one of these three, we're going to progress past rectangle and rhombus and go all the way and say that our shape is amazingly more specific. That's an interesting E. And progress on and say that the shape is a square. That's an awful arrow. If you make a mistake, just make it darker. Okay, so this page is going to be really important because I don't think you want to remember all these conditions. But again, it's about walking the path. If I'm asking you whether you have a square, you have to first prove that it's a parallelogram, then prove it's a rectangle and a rhombus. If you can get one of the 6 conditions for a parallelogram, one for a rectangle and one for rhombus, then that's the only time you know that you're going to be looking at a square. These conditions are important. You need them. You need to review them because in class, we're going to practice over and over and over on these problems. All right. So please have this information available and easy to access. All right. And be in class because this is a tough thing to practice. Good luck.